So the overview, actually, this follows your presentation quite closely in terms of the recipe. So I'm watching your presentation like, did you see what I had to do? Do we copy each other? So it's actually going to be very simple. What is FEWSnet? And what type of data sources and visualizations do we have? An overview of select FEWS products. We have quite a few products that might be useful to everybody here. And finally, how we do our seasonal forecasting for our end users, which happen to be the folks in Africa. So the first thing I'm going to discuss is what is FEWSnet here. So FEWSnet is the Famine Early Warning Systems Network. And FEWSnet is actually older than I am. So it's been going on for quite a long time. It's been doing a very good job, and it's constantly evolving. So that's something that's obviously very, very, very important, that we're constantly learning, we're gaining new partners, we're gaining new research, we're gaining new insights. So USAID, which stands for the U.S. Agency for International Development, which is basically the top-level body for FEWSnet. And within USAID, there are these two, I guess, sub-organizations. FFP stands for Food for Peace. And DHCA, I don't remember the acronym. It's Democracy and something or other. So anyways, within USAID, in this governing body, there's FEWSnet right here, Famine Early Warning Systems Network. And the goal of FEWSnet here is for national and regional and international food security and assessment partners. So we're basically assessing food security for the end user, which are the folks in Africa. So FEWSnet contracts out, I shouldn't say contracts out too much, but it utilizes a lot of government agencies, NASA, the U.S. Geological Survey, NOAA, and the USDA. And each of these organizations have an integral part. They do their own sort of thing. So NASA does a lot of the remotely sensed products. There's some folks who do hydrologic modeling, crop modeling within NASA. USGS as well. USGS tends to do more on the ground stuff, crop assessments, NDVI, things along those lines. Then NOAA here, which is the National Oceanographic and Atmospheric Administration, does a lot of the weather research and in terms of like monthly and weekly hazards. And then there's the USDA, who's also involved. Now in the middle here is Chemonics, and Chemonics is the contractor that basically does the food security analysis. So they take all of the information that we have, and the people over at Chemonics do the food security analysis for the people on the ground. So all of these bodies here work together and try to bring a more food secure world over these regions. Now FEWSnet countries are quite broad and spread out across the world. They're broken down into these sub-regions here, the first one being Central America and the Caribbean. And there are a number of different countries over Central America and the Caribbean that we look at. But FEWSnet really began over Africa, in sub-Saharan Africa. So it can be broken down into really 4 main regions. The first one being West Africa, anything really west of Chad. East Africa, anything east of Sudan. Southern Africa, which depending on how you look at it, depending on the precipitation zone that you look at. So the southern part, which happens to be unimodal, is more Southern Africa-like, whereas the northern part is more bimodal and has more in common with East Africa. So anything probably in the middle of Tanzania is Southern Africa, and anything north of that is East Africa. We recently added Yemen, Yemen being sort of the Middle Eastern region, even though it has really a lot in common climatologically with East Africa. And then finally Central Asia, Afghanistan, and Tajikistan. So there are quite a large expanse of countries that we're interested in, and we do a lot of research over and do food security analysis and so on and so forth. Now these are the FEWSnet objectives. So FEWSnet has a number of different objectives. It has a lot of responsibilities here. And where we reside is the weather, climate, and crop monitoring and assessment. And specifically, weather and climate monitoring is what I do and what my close collaborators do. The monitoring assessment happens to be with close collaborators, but not too close. It's not like we're on the phone daily with them. And really what we're interested in is real-time weather monitoring and early warning. So early warning is the reason, is what we do. We're trying to understand what is going on over these regions. How can we support people? How can we give them a heads up as to what's going to happen in the future? Agricultural assessments, livelihood adjustments, and adaptation to climate trends. And there are three other main components here that our partners, they end up doing. And these other three components here are really what that company called Chemonics does. And there's food markets and trade monitoring and assessment, really that human dynamic, health and nutrition, and subnational livelihood frameworks of food security. So what we do here in terms of our weather, climate, and crop monitoring assessment and trying to understand the causality of climate, they can then draw some conclusions based in terms of the human dynamic here. So that's FEWSnet in a 5-minute, in about 5 minutes. People have put together hour presentations on FEWSnet, so if you have any questions, I can try to answer those, and if I can't, I'll direct you on to the people that can. So next in line here, we'll talk about the FEWSnet data sources and visualization. I see everybody has a computer here, and I'm going to make use of a lot of screenshots here and a lot of the things we have available on the web. So if you wanted to use your computer to just follow along, you're more than happy to do so. So the first thing I'll talk about is the map viewer. So how we visualize basins, crop zones, and irrigation. And this is really some high definition pictures of the attributes of certain areas of the world that we look at. So again, this is our map viewer. So this right here is the FEWSnet homepage. And the FEWSnet homepage is just earlywarning.usgs.gov/FEWS. This is what the page looks like here. And the first thing we're going to talk about, like I said, is the interactive map viewer. So the way you get to that is you go to software, you kind of scroll your mouse on over that, and you click on interactive map viewer. When you click on interactive map viewer, you get a map of the world. And this is only tuned to looking at regions that we're focused on, so Central America, Africa, Central Southwest Asia. And I'm interested specifically in Central Southwest Asia, and in particular Afghanistan, which is the reason why I chose this here. So in the top left here, if you click on a country like Afghanistan, it will zoom you in on this country like so. So here's Afghanistan. And what you can do is you can turn on all these different map layers. So irrigation, rain-fed, rangeland. You can even turn on basins as well. And the benefit to this product here is that you can zoom in to these really high resolutions. You can zoom into somebody's house if you really wanted to, and you could see where somebody lived within these different areas, within these different crop zones. So these smaller polygons in here are the crop zones. The green is the rangeland, the blue is the irrigation, the orange here is the rain-fed crop. So you can get a sense as to where one person lives or where something lies within these different crop zones. So it's a nice little tool. And you can use this for all the different areas of the world that FEWSnet is interested in. So the map viewer is constantly being utilized here. So it's a little bit, it's not a new product, but it's constantly being added, more things are being added to it. And there are two things that you can look at specifically here. There are NDVI and rainfall, so RFE rainfall. So what you can do is you can click on a time series, click time series, there's a button right here. Click on a region, I click on this region here into the northeast of Afghanistan, and it comes up with this window. You can show time series of NDVI or RFE by clicking on this box right here. You click on said box, and then you can manipulate what precipitation, temporal precipitation you're looking at here. So everything is shown in terms of Dekad, so 10-day windows and 10-day periods. And this is a nice tool. There are other tools that we have that are a little bit more developed. That can do a little bit more than this because this is still being implemented and still being sort of brought up to speed here. But this is kind of the way that we're going in the future. So it's a nice tool, and definitely keep it in mind. So going back to the overview now, the FEWSnet data portals. So in our FEWSnet data portals, this is really important for me in terms of seasonal forecasting, in terms of, and for my colleagues as well. The people on the ground, the people here in I was going to say here in the United States, but we're not in the United States. Certainly for the people in the United States. So the FEWSnet data portals are made of pre-existing visuals of regional data products. So this is a nice website. So you go back to our homepage, which again is earlywarning.usgs.gov/FEWS, and you scroll over data portals, and it's broken down by the regions that we cover here. So the first one being Africa, the central one being Central America, the third being the Middle East. We have an interesting thing here for South Asia. We really don't have many products, or we don't have any monitoring over South Asia, but it's a choice, so you can look at it. Then Central Asia and global. So what I'm going to focus on here is Central Asia, again, because of my Central Asia interests. So I'm being pretty self-serving when it comes to that. So when you come to this page and you come to all the other pages that happen to come up in data portals, whether it be Africa or Central America, you can come on these pre-existing plots that show up here. And some of the things that you can look at are things, I know it's a little bit small, it's even small for me to see here, like NDVI, rainfall, temperature. There's some snowfall things for certain countries. You can click on these and you can get a sense as to what's going on. They're constantly updated. I'm actually amazed at how quickly they're updated. They're updated usually the day after the product comes in. So it's completely automated. There's really no human having to push the button, and if they get sidetracked, then it doesn't get updated. So it's constantly updated, and it's very, very useful. So here's an example of what the decadal precipitation anomalies are over Central Asia. So for this case, Central Asia is defined as anything from Iran to the west, to the east into India, China, really it's Pakistan, and then north into Kazakhstan. Up top is decadal rainfall. Down below is decadal rainfall anomalies. So with that being said, this is just an example here of just being able to use some of the FEWSnet data resources that exist online. They're nice, quick, and easy products to kind of go and look at what the climate is doing and how it's behaving and how it impacts crops and soil moisture. I was going to say soil moisture will actually be something I'll cover in a little bit. But NDVI, I figured I'd show another example of NDVI. So this is Emotus. Click on that, and you come up to our page here for Central Asia, and then looking at here is the percent of average. Fortunately, thought to use Central Asia here. In Central Asia, it's not the rainy season. It's the middle of the summertime, so there really isn't any NDVI anomalies. So not a great example to look at. There are some anomalies here over the monsoon region of Pakistan and into India here. But yes, this here is our NDVI, one of a product that we put up on the web. So it's nice and pretty useful for folks to look at. So the FEWSnet data portal summary, it has nice pre-made graphics, and it shows important variables for regionally or for individual countries. So you might want to consider looking at that if that interests you. So here's some examples of variables. This really isn't an exhaustive list. It's not a complete list either. So various rainfall estimates, whether it be RFE or a new product that we've developed in-house called CHIRPS, NDVI, soil moisture, WRSI, snow and snowpack variables for Central Asia, and various atmospheric circulation variables. This is actually something that personally I'd like to see a little bit more of in terms of our data portals here, and hopefully we can do that. And again, the regions: Africa, Central America, Middle East, Central Asia, South Asia. So whipping through here in the overview, our FEWSnet data sources and visualization, the Early Warning Explorer. So this is user customizable visualization. It actually has a lot in common with the map viewer. I think they're actually made from the same sort of code. So the way you get to the Early Warning Explorer is by going back to the home page, going here, clicking on Software, and going to Early Warning Explorer. So this is the page that you come to. It's actually rather dull and rather blank, and it's kind of strange for all of our FEWSnet pictures because all of our pages have so much on them. So we have 4 products that you can show here in the map viewer. This is going to be added to in the future. This is something that is it's a pretty new product or a new visualization tool that hopefully we can start implementing a little bit more into. So currently you can look at RFE, land surface temperatures, NDVI, or this precipitation product called CHIRPS. And again, I'll talk about CHIRPS in a little bit. CHIRPS is something that our group is very proud of. So I chose CHIRPS, which is kind of in the general theme of the presentation here. If you click on CHIRPS, it'll give you a map of Africa. And it'll zoom in on Africa on its own, but you can zoom in as far as you want, or as far out as you want. It really doesn't matter. The scale at which you look at is totally customizable here on the zoom and the toggle map. You can display the variable in a couple of different ways. You can show it in terms of total precipitation, precipitation anomaly, and here the sigmas for standardized anomalies. They call it in-house as z-scores. So if you see z-score on the website, if you go look at it, that's all it means. It's a standardized anomaly. And you can choose the time. Obviously, it wouldn't be useful if you couldn't choose the time anyway. So the year button is here. CHIRPS goes back to 1981 to the near present. And you can choose a season here, or a month. I happen to choose a season here of March, April, May of 2000. And I chose that anyways because East Africa was dry then, Southern Africa was wet, associated with La Nina during that season. So CHIRPS precipitation is something that we're sort of rolling out now, and I'll sing the praises of CHIRPS in a little bit. And this tool right here is a really nice visualization tool. You can look at these other products here, RFE2, LST, Emotus, NDVI. So here's the overview of select FEWSnet products, and here I sort of begin the meat of the presentation here with the overview of the select products, and then going into our monthly seasonal forecast review. So here's CHIRPS Rainfall. CHIRPS Rainfall is a rainfall product here that it was created by UC Santa Barbara in collaboration with the USGS. And the purpose of CHIRPS is to be able to use it in land surface models and crop models, which is why its spatial resolution 0.05 degrees by 0.05 degrees was created. So CHIRPS stands for the Climate Hazards Group Infrared Precipitation with Stations. It's a play on words, obviously a bird chirps, so there's the name right there. Its spatial resolution, again, 0.05 degrees by 0.05 degrees. The only problem here that I see is it exists from 50 south to 50 north. And that's really because of the way it's a remotely sensed data product in terms of satellites. I'd like to see it personally go a little bit further north and south than 50, just for my own selfish needs in terms of climate variability and large-scale climate variability. But this is where it's at right now. And it does more than enough here in terms of the regions that we cover with FEWSnet. The temporal resolution is available. We have daily product. We have a pentattle product every 5 days and a monthly product. And the release date, it's actually kept, the folks who curate this data product, they keep on top of very, very nicely. So days and pentads are available 2 days after a pentad ends, and oftentimes even a day after a pentad ends, and every month by the middle of the following month. So we've just hit the 15th of September, or a little bit past the 15th of September. August is available now on the website. Where can you go get CHIRPS download? Where can you download it? You can download it at our webpage in Santa Barbara, and it's chg.geog.ucsb.edu/data/CHIRPS. So you can go and get that CHIRPS download. It's available in binary files currently. It's not available in NetCDF quite yet, even though I keep begging them, banging on the door. Come on, guys, come on. I'd like to have it in a NetCDF file myself, but all the users seem to be satisfied with the binaries that we have. So I'm going to talk about the construction of CHIRPS, a little bit of how we make the sausage here. It's really not a whole lot different than a lot of other precipitation products and how they're created from satellite data. I can only go over to a certain degree because I wasn't the one who coded this. I'm not the brain behind this, but I know enough about it to discuss it, and I'll actually have you email the people who are in charge of this if you have any further questions. So there are 4 main steps here in the construction of CHIRPS. The first is creating a historical precipitation climatology, and this is called CHP_CLIM. And I have individual slides that discuss this. We'll outline that in a little bit. The second is to calculate the precipitation estimate using the infrared data from the satellites, and it's called IRP-ERP. We love our acronyms in Santa Barbara. And then we apply time variability of ERP to CHP-CLIM to create CHIRP. And then we merge quality control and blend the stations in to create the final product called CHIRPS. So the creation of the monthly climatology, CHP_CLIM, I didn't know this, and it was something interesting. Apparently a lot of Met agencies, they have really extensive monthly climatologies for their individual regions. So we've taken all of those monthly climatologies that were available to us, in addition to a lot of station data, and we have built a monthly climatology based upon this. So the backbone of CHIRPS here are these really stable monthly climatologies that exist. And this happens to be, I believe it's from May.
How long?
81 to the present. Yeah, that actually, I don't think I put that in here. Yeah, 81 to the present is the temporal variation of the temporal extent of CHIRPS.
This is climatology.
This is the climatology. This is 1 month. This is climatology for 1 month. Yeah. So I needed a picture. Grabbed a picture from our sort of picture repository, and this is what it happens to be right here. So this is the climatology for the month of May. And then we use, for steps 2 and 3, we calculate precipitation estimates from infrared radiation. So the principle here is that if you have a taller cloud, you have a colder cloud. And if you have a colder cloud, you get more rainfall associated with that. And that's basically what we're showing here. This is just a linear regression onto the infrared time series. So you regress cold cloud duration, CCD, to trim V7 pentad precipitation at each pixel for each month, and you calculate near real-time precipitation from the CPC, that's the Climate Prediction Center, infrared radiation, available at 1/2 hourly. And then you apply that IR data to the 1981 to 2000 to extend the IRP, the infrared precipitation product time series. So this is how we sort of put together the template.
You can get half-hourly.
Yeah, you can get the half-hourly data if you want to. It's a lot of data. Sort of on our drives in Santa Barbara, we have all this data here. So we've made these calculations every half-hourly and sort of aggregated them in order to put together the precipitation time series.
This half-hourly is based on what satellite we use?
It's the CPC infrared satellite. It's the one that went up in it's been up there since the 1970s. Yes, it's a geostationary satellite.
And you used a couple of them.
Yes. Yeah. Yeah. I mean, a lot of like trim is used in here. Trim is a baseline, and then it's corrected against CPC, the CPC infrared product. So there's a couple of different infrared products that are used in here. And then finally, we have this infrared precipitation product, CHIRP, and then we blend in the stations here. So this is just the monthly precipitation stations over Africa. You can see actually back to 1981, there were a lot of stations available. And as we've come up to the near recent period, things have actually dropped off sort of with a linear trend, if you will. So there are 21 sources of these stations here from global, regional, and national. It's interesting how we got our hands on a lot of this station data. It turns out to be there's so many different data sources that you're constantly saying, oh yeah, well there's a new data source and this and this. So we're constantly updating CHIRPS with more data sources that sort of come to light throughout time. And that's really important. So CHIRPS is sort of ever evolving. There are 198 stations with duplicates and 5 million daily rainfall data since 1981. I don't know why this is on here on the slide, 500 million back to 1832. I guess we're trying to impress somebody. But back to 1981 here, 500 million daily rainfall data. So this is what goes into CHIRPS here. This is what we blend together with the infrared precipitation product that we've created. How good is CHIRPS? CHIRPS was just rolled out about 6 months ago, and we're constantly trying to evaluate CHIRPS. And people are using CHIRPS in their learned service models and in using CHIRPS in their daily research, like I am, when it's appropriate. My research goes back decades and even multi-decades, so sometimes it's not appropriate, but I use it sometimes, and I'm able to get a sense as to how good it is, and it's actually pretty good. It's quite impressive. This bottom plot here is the Longhorn, this should be the Eastern Horn, cross-validation for May. And you can see that even though the number of stations have decreased quite a bit over the Greater Horn, the error levels are reasonably constant in time for CHIRPS. So we're actually we're encouraged by that. It's very nice. So how good is CHIRPS? Another way of validating CHIRPS. So here's the wet season map for each of these regions. I love this map. I think this map is just wonderful. I didn't make it. Somebody else in our group did. And it just shows the wet season at each pixel here. So the wet season being defined as the 3-month period that receives the most rainfall. So with that being said, if you were to look somewhere over East Africa, the long rain season, the March, April, May season is actually the season that gets the most rainfall, which is why it has those colors right there. And you can follow this over all the other regions of the globe for the CHIRPS region. So basically what we did is we started comparing CHIRPS to a number of different data sets. CFS, which is a reanalysis data set, the CPC Unified Precipitation, CHIRP, which is just the infrared product, CHIRPS, which is with the station data, ECMWF, and TRIM. And we all compare them to GPCC. GPCC is the product. It's a European product. It's a product I use quite a bit, and it's built solely on station data. So what we do is we then compare the wet seasons for GPCC with the wet seasons for each of these products. And what we see, and these are correlations here of each of those products that I outlined before, CHIRPS does a really, really, really good job. You probably can't see this, but this correlation of 0.75 is the darkest blue color, and a red color here is basically no correlation. You see next to no areas of red in CHIRPS. There's a little bit of an area sort of over central equatorial Africa. But for the most part, it's actually very, very blue, and more blue than each of the other products that you see here. So CHIRPS gets a thumbs up here in terms of its comparison to the solely station data against, say, TRIM or RFE2.
Oh, next round in the US.
Hmm?
Next round. US. There's no next round?
Hmm?
Next round.
Oh, no. Actually, that's a really good point. You should probably compare it to NextRed. NextRed's actually probably really good. I don't think they even considered that.
You should suggest to Chris.
I really should suggest to Chris. I don't know. That's a really, yeah, that's good. So here's another product here. Here's the GeoWRSI. I'm sure all of you are aware of WRSI and use it. Here's just a standalone version that UC Santa Barbara has developed. You can find it in software, going back to our homepage, software, and GeoWRSI. I don't have a Windows machine. When it only runs on a Windows machine, so if you have a Windows machine, you can use it. I don't personally have any examples here, but I point you to the website here and go and look at it and see if it suits your needs and something that you might want to use. So what is GeoWRSI? What are the program outputs for it? And what are the related tools? A lot of our regional scientists use this quite a bit. So when we do our seasonal forecasting, this is a mainstay in some of our products here. I see these maps all the time. I see them in my sleep when we do our seasonal forecasting once a month. The last thing here is what we call the Decision Support Interface, DSI. So what the DSI is it's a product that is used to help our food security analysts not have to make so many decisions on their own. Our food security analysts make a lot of decisions. They have a lot of responsibility, and the responsibility is very important because they are the people that work with the end user and support the end user. So any way that we can help them make decisions that are objective is very, very good. So the way you get to the DSI page is you go to Software and Decision Support Index like so. So this is the text that pops up on the Decision Support Interface website. The DSI is actually a very, very new product. It's something that came out in just the last couple of months. It's something that we're trying to integrate right now. And it's actually something that we're constantly trying to tweak, and it's evolving. It's going to change. I'm going to present to you something about this today, and the recipe is just going to change anyways. It's going to be tweaked a little bit because we don't feel that this right here encompasses everything that it needs to encompass. So the DSI is an experimental decision support tool on weather and crop conditions. So it incorporates weather and crops and puts everything together. It incorporates drought monitoring rules that distinguish severity and provide a generalized drought indicator at national and subnational scales. Results are preliminary and should be used with caution. So yes, use them with caution if you're going to use them. The good thing here is it's a standardized and objective support tool. The bad thing, and this is something that I'll touch on in a slide or two, is that it treats every crop zone the same. And we know that a crop zone over, say, some part of Tanzania is not going to behave the same as a crop zone over Afghanistan. And currently, as it sits right now, they're treated in the same sort of way. So with that being said, that is really the only drawback that I see to this here. There are 5 input variables currently for the DSI, and the 5 input variables are 1 Dekad rainfall anomaly, 3 Dekad rainfall anomaly, 6, and 9 Dekad rainfall anomaly. So rainfall anomalies are very important in the DSI, as well as 1 Dekad NDVI anomaly. So what we do is we then take each of those input variables, and they're converted to percentiles and assigned a category of 1 to 4. This actually is very, very similar to the US drought monitor here. The color scale is very similar. The way things are sort of broken down into the -1 to 4 categories, very similar as the US drought monitor. So you may have seen this before. So anything that has a greater than 30 percentile of these variables in the historical context are given a category of -1 and are called normal. Normal is a good thing. However, 0 to 4 aren't necessarily good things. And they're broken down as from 21 to 30, it's given a 0, 11 to 20, which is given a category of 1, 6 to 10, which is 2, 3 to 5, 3, and 0 to 2, which is 4 here. So this is how we break down each of these variables and sort of put them into context here, from normal to exceptional drought. And then what we do is we calculate the DSI, the decision support interface, based upon those variables using this recipe. So what we do is we compute the DSI every decade between the time that crops are planted and the time when crops are harvested. And all other times are considered out of season. And the weighting of the input variables to calculate the DSI, they vary within the growing season. So we break down the growing season into 3 parts. The first third of the growing season, what are heavily weighted is the 3 and 6 Dekad rainfall anomaly. In the middle third of the season, it's 6 and 9 Dekad rainfall anomaly in addition to NDVI. And the final third of the season is the 9 Dekad rainfall and NDVI. And the final DSI is assigned a category of 1 to 4 based upon this weighting. When I say heavily weighted, it's very, very heavily weighted upon these variables. There is some input from each of the other variables, each of the other 4 or 5 variables that we have, but these are the heavily weighted variables. It's going to change, the DSI is going to change the recipe, so this isn't going to last very long. And I don't actually know what the new recipe is going to be. So if you ask me, I wouldn't be able to tell you. But at current, it looks like this. So the DSI is nicely mapped out here in our map viewer. So I'm just going to run you through this here and show you what it looks like in our map viewer. What you want to do is you want to select a region here on the left, say for East Africa. Then it gives you all these countries, say Burundi all the way down into Tanzania. So you click on them all, and then it will give you these DSI values over all these different regions. You can select a time, and for this one right here, this time happens to be for the first decade of February of 2014, and it will show what the DSI looks like over the regions that we have asked it to show. When things are grayed out like right here, it means that it's out of season, and yes, Kenya's out of season, much of Somalia is out of season, Ethiopia, in terms of the precipitation season, so that's why it's grayed out. You can then click on a crop zone table, and then for each individual crop zone, you can then get the value of each of the input variables for the DSI here. So you actually see quite a bit of green, which is good. It was pretty good to start out the season. And if you click on the legend, you then get the sort of coloring here from normal all the way down to exceptional drought. So that being said, you can then scroll through the season and get a sense as to what the season looked like in terms of the DSI or the support interface. I chose this season here because it was sort of present in my mind, but also it really showed the dichotomy of the season. So if you looked at East Africa quite a bit over this long rain season, you'll know that what ended up happening is it started off really, really well. It rained quite a bit over East Africa, over the Greater Horn, and then the rains just stopped in April, and it got really, really dry. And you can actually see this right here. So you see the evolution. It looks really green, and then it stopped raining. We do seasonal forecasting with them. We work with them daily, but this is a really nice tool for them to take away that decision making from them. So going back to the overview, and the last point here is the FEWSnet monthly seasonal forecast review. I invite you all, if you'd like to be part of this process, you can participate. We meet 2 days per month on a Wednesday and a Thursday. A Wednesday we meet for about 2 hours, and a Thursday we meet for an hour. And the next one will be happening in the middle of next month. The last one we had was just last week. We hold it at 7 a.m. Pacific time, 10 a.m. Eastern time. So folks who are in Europe, come participate. Unfortunately for you folks here in Asia, it's a little off time, so it'll be a little late for you. It's actually made to go like that, so the people in Central Asia can participate, being 8-9 hours ahead of the folks who are on the eastern US. So the monthly seasonal forecast review, the purpose is to aid the development of agroclimatology assumptions used by FEWSnet food security analysts. The food security analysts, they make these assumptions for precipitation and temperature so they can try to understand what's going to happen in terms of cropping over the next 1, 2, 3, 4, even up to 8 months. And they use these assumptions, and these assumptions are very, very, very important to them. And they take this very, very, very seriously. So we have to be on top of our game and do a really good job in terms of trying to understand what's going to happen with the climate and to try to direct those assumptions in the right direction. So the regular contributors are NOAA, USGS, UC Santa Barbara, and NASA. And we have occasional participants at the Caribbean Institute of Meteorology and Hydrology at Princeton and others. And they are very, very, very infrequent. So the monthly forecast review, what are agroclimatology assumptions? These agroclimatology assumptions, they summarize the expected behavior of the climate in terms of temperature, precipitation, snowfall, and soil moisture on various timescales. And the typical focus is usually for about a 2 to 4 month window, and occasionally a 4 to 8 month window is used. These food security analysts, they aren't climatologists. They sort of learn on the go, and they learn from us. So it's really important for us to do a very good job in supporting them because it's not their expertise, and we understand that. So we really have to do a good job. So used by food security analysts to better understand the most likely climatic conditions directly responsible for crop conditions and crop yields. And we try to give them exactly what they want. So here's an example of an agroclimatology assumption. This is actually kind of a weak assumption, but it's a simple assumption nonetheless. And this was for the last, I think this was probably made in January of last year for Southern Africa. Following the intensifications of rains in December, near normal amounts of rainfall are likely to continue from January to March in much of Namibia, parts of Botswana, southeastern Angola, and southern Zimbabwe. And we'll revisit this in a couple of slides as to how we address these assumptions. So the monthly seasonal forecast review calendar, we do have a calendar here. We have set dates that are based upon when products become available. So this is for November 2013. On the 8th of that month, the global climate models, their forecasts are made available, and they're actually updated on the web on the 9th. They probably weren't updated that month until the 10th because it was over the weekend, which is why on the 13th, we then were given our assumptions. So to put this in sort of graphical perspective, the climate model forecasts are released on the 9th. On the 13th, the Home Office just stands for the food security analysts. They distribute draft assumptions to the review committee. The review committee consists of myself and Jim Burden. On the 18th, the climate scientists, we have our webinar. This is our 2-hour conference call where we then go over what happened, what's going on in the climate, and we address these assumptions. And then on the 19th, we then discuss with the food security analysts. So our climate scientist webinar, the purpose is for our scientists to review the draft assumptions in light of climatology, climate modes, seasonal forecasts, and observed data. And we basically have quite lively debates. Everybody has their own perspective as to what's going to go on. And what we end up doing with that is we put together better assumptions. So the process of the Wednesday webinar is the first thing is NOAA CPC presents the state of the global climate. And then we present evidence to present confirmation or revision of the draft working assumptions. We comment and debate, and then we create consensus assumptions. So this is actually it's a very lively webinar, and if you like scientific debate, this is probably for you. You would really, really enjoy this. This is a really fun part of the job. And then for that Thursday webinar, which usually lasts for an hour, we present revisions of the working assumptions to the food security analysts in light of the likely climatic scenarios. A lot of the science partners don't participate in the Thursday call because it's really a summary of everything that happened on Wednesday. I put together this summary and then I present it to the food security analysts. So if you do want to participate, you don't necessarily have to participate in this or even sit in on this. This one is probably the one that you'd like to see. So how do we address assumptions? So again, the example of the working assumption from before is following the intensification of rains in December, near normal amounts of rainfall are likely to continue from January to March in much of Namibia, parts of Botswana, southeastern Angola, and southern Zimbabwe. So what we ended up seeing is we saw a different climate scenario than the assumption. And what we ended up doing is saying, following the intensifications of rains in December, we crossed out near, we said normal to below normal amounts of rainfall are likely to occur from January to March in much of Namibia, parts of Botswana, southeastern Angola, and southern Zimbabwe. So this is a simple modification to an assumption that we do based upon the global climate forecast and all the information that we have at hand. So this is the way that we are able to support our regional food security analysts and the people on the ground. So what have we discussed? You've seen this slide about 15 times. You probably have it memorized by now. That ends the presentation then. Thanks for having me. I've really enjoyed being here so far.